Production funding for QED with Dr. B is provided by
Battelle cares about STEM because it was part of our founding. Gordon Battelle, our founder, believed in building an institute that would actually better society through the use of science and technology. And this year we're going to hit a goal of 1 million students a year that we'll be able to impact around the country.
American Electric Power Foundation, boundless energy for brighter futures. And by viewers like you. Thank you.
I'm Dr. Frederick Burtley, scientist and President and CEO of COSI. Welcome to QED with me, Dr. B. Let's talk about science.
Today we're talking about forensics, and I'm looking forward to this because I love those true crime shows where the smallest piece of evidence breaks open this huge case. But Dr. B, some of our experts talk about this thing called the CSI effect. Can you break that down for us?
Sure, there's been so much great television, detective shows, law enforcement shows, and they show a lot of science out there. And so it's embedded in the regular community, so average people who end up becoming jurors in real life think that a lot of that stuff is absolutely accurate. So they're looking for cut and dry data, no nonsense, and a lot of it's fiction. So that's why we're here to separate the facts from the fiction, and that's why we're going to the experts, and that's the mission of this show.
Well, later on, we're going to talk about the advances in DNA identification and then the reliability of firsthand eyewitness accounts. But first, Dr. B, let's talk about fingerprints. What did you find out?
Fingerprints is a fascinating area to study. We all know about the little swirls, and that's cool, and that is actually used, but it's so much deeper. The scientific information that is positioned on each of our fingertips is outstanding. To dive a little deeper, I talked to Simona Francesi, professor of forensic and bioanalytical mass spectrometry at Sheffield Hallam University. Your research indicates that there's more to fingerprints than just lines and swirls. What kind of information can we get from a single fingerprint?
Essentially, what a fingerprint is the sexy version of sweat. And sweat is a biological matrix, so there's loads of molecules there. Because these molecules are sitting there, you can detect them and they can tell us a story about you. And so we've been able to, with the technology that we've developed, to detect these molecules and then gather information about a certain person. So your sweat profile actually changes during the day. It changes with your metabolism. It changes with physical exercise. It changes if you are anxious or scared or preoccupied about something. But what is interesting is maybe not the overall composition of your sweat profile, but what can be found at a particular time when you take that fingerprint and analyze it. And there are some molecules that we say they are persistent. They can still be detected after a long time.
Wow, that is fascinating. So the fingerprint is not just a series of swirls and grooves, but it's really like a chemical capsule of stuff inside your body. What technology are you harnessing here?
So the technology isn't new. It's been around since the 80s, and it's got a very long name. It's matrix-assisted laser desorption ionization mass spectrometry, or MALDI in short. And with this technology, you can detect molecules and you can also visualize the molecules. And by using a laser and firing this laser, which is a UV laser for simplicity, and you fire at the surface of the item where the molecules are sitting. And what happens when the laser fires on these molecules is that the molecules come out at that surface. So we say that they desorb. We also charge these molecules, so it's a different version of a molecule. We call it an ion. But it basically is a molecule with a charge. And what is interesting here is that by measuring how much this molecule weighs, we can actually link the molecular weight or the mass or the weight to the identity of that molecule. So we can say what that molecule is.
Can you give us an example of how this technology has advanced forensic research thus far?
If you imagine a scenario of a rape or a sexual assault where the assailant wears a condom, the simple action of handling a condom would contaminate the fingertips of the offender with the polymers, the lubricant and the polymers that are contained there. And so if then the offender touches a surface, it will leave a fingerprint. But not only that, it will leave a fingerprint made in this condom lubricant. And so what we've been able to say is that this particular fingerprint contains this particular polymer, which belongs to this particular condom brand. And I can also show that this polymer is distributed very well all around the fingerprint, so much so that I can see a new type of image of a fingerprint, which is a molecular image of the fingerprint through the polymer they've just detected. So if the offender thinks that by wearing a condom he can escape justice because, there's no DNA left behind, well, that fingerprint kind of nails him down, because I can provide the biometric information plus the circumstances of the crime, linking him to the actual crime.
Yeah, absolutely. Absolutely. Can you also talk to me about this kind of overlapping fingerprint phenomenon?
So here's the thing. If you imagine a scenario of two people touching a surface in a way that eventually the two fingerprints are overlapping, well, what we can do is, if you imagine that each fingerprint is made by thousands of molecules, do you not think it's likely that at least one molecule is only present in your finger mark? And so it's unique to your finger mark. And then I have at least another molecule that is unique to my fingerprint, right? So then what the technology can do is visualize those unique molecules one at a time. Yours first, and that means that only your finger mark shows up in our software, then mine, and then my finger mark shows up only in our software. And in essence, you have separated the two patterns, because those molecules will be uniquely present in one or the others. We tried this with 6 fingerprints, and you can see that you can separate all 6 fingerprints. So the likelihood that there is at least one molecule that is unique to yours allow us to separate these rich patterns.
Terrific. So how are you hoping then that this technology develops?
So I'm now at a stage where this technology has been integrated into the finger mark visualization manual, which is edited by your office and now the Defense and Science and Technology Laboratory. And that is the Bible that tells CSI and crime scene operational managers how to deal with fingerprint evidence. Now, the legislation system is obviously different in every country that you look at. So to generalize and say how this can be transferred to US or to the rest of Europe, it's going to be quite difficult. It has to be looked at individually. Even handling the evidence is different in each country. But of course, I am working on a global scale as well. I do have international partners. And so although this is a long, slow journey, it's one that will happen in the end. And my hope is that this technology will be used in major crimes.
So DNA profiling has become the golden standard for forensic science, and a lot has changed in the last 36 years since it was first used as evidence in the courtroom. So what has been the narrative of DNA evidence gathering throughout the years? Is it faster? Is it stronger? More reliable?
Yeah, you nailed it. It's been around for 36 years. And really the heart of the DNA analysis is really the subject called molecular biology. And we know so much more about the science of molecular biology. It's advanced in greater numbers. The technology is really available and accessible. So what it does is it makes things much faster, so to sequence DNA and look at the actual evidence. And because of the proliferation of technology, it's also much cheaper. And so now it's accessible for all local law enforcement.
Well, and now there are newer, bigger DNA databases that gather evidence from multiple crimes. Can you tell us more about that?
Yeah, we hear about big data all the time in society, and really this is the massive computational power that we can now use to analyze stuff. And now we apply that in forensics. And so what's been happening is you've gone from having local databases connecting now to statewide databases and even national databases. And so putting all that information together, law enforcement have been able to really pinpoint deeply and precisely on certain crimes. And for more on that, I talked to Abby Schroederer, the Quality Assurance Manager at the Ohio Bureau of Criminal Investigation, run by Ohio's Attorney General. As humans, our DNA is roughly 99.9% identical at the genetic level. And considering DNA is made up of 4 simple letters, A, C, T, and G, what kind of tests are you actually using, and what are you looking for when you're doing this DNA analysis?
The one that's predominantly done in crime laboratories is something called short tandem repeats, or STR testing. And those building blocks of DNA that you mentioned, the A, T, C, and G, we're looking for specific patterns and repeats of those building blocks in someone's DNA. And the regions that forensic scientists look at is highly discriminating. And that discrimination power allows us to distinguish one individual from another when we're trying to identify potential sources at a crime scene.
How accurate is the methodology, and what is the possibility for false positives to pop up?
I've personally reported statistics where I would expect to see that profile one time in 5 quintillion individuals tested. So it is very accurate. But that being said, we're not testing the entire genome of DNA with every forensic case. So the possibility exists, however, very rare.
The sheer amount of DNA data that the FBI has now. What is this database, and how is it changing the whole field of DNA evidence?
The FBI's database is called CODIS, which stands for Combined DNA Index System. So this is a database that's utilized at the federal level, the state level, and the local level. So crime laboratories throughout the country can utilize this tool to search electronic DNA profile records. And it's used every day to identify individuals who may have left their DNA at a crime scene, and also to potentially link cases together.
What are the types of cases that CODIS can help solve?
Crime labs can put DNA profiles in from anything ranging from a property crime to a homicide case. And that's the power in the database. You may find several property crimes that are linked together, and then years down the road find that it's linked to a homicide or even a named individual at that point, really helping to move the investigation along for investigators.
Tell us about the Stephanie Hummer case.
Stephanie Hummer was a student at The Ohio State University back in the mid-90s.
Yeah, I remember this case well. It was 1994. Stephanie Hummer was a bright OSU student who was abducted from campus, raped, and killed. The case shocked the entire community. The FBI DNA CODIS database didn't exist. The case went cold. Fast forward to 2005, the state expanded its DNA database to include all felons and people convicted of 11 of the most serious misdemeanors. And that's when they had a match, Jonathan Gravely.
And they were able to investigate further and eventually led to a confession in her case.
So some criminals are not found by a match of their own DNA, but by their relatives' match in CODIS. Can you tell us about the Justin Christian case?
So back in 2016, a 6-year-old was abducted and assaulted in Cleveland.
He opened her bedroom window and grabbed her by her legs. He told her to come with him, and if she screamed, he would kill her whole family.
But she fought him off, and he fled, leaving DNA on a ladder he used to get to the window.
We did a search in the DNA database, but there was no match. So this was a good candidate for something called familial searching at our laboratory. And this type of test utilizes the CODIS database, but applies a separate statistical analysis to try to identify relatives of any person who might be residing in the database.
Christian had a deceased brother who had committed a qualifying offense and whose DNA was in the CODIS database.
That led to Christian, who had been driving his dead brother's car as he stalked the victims and was caught on surveillance video. Justin Christian will have 35 years to think about his crime. Now, that's 35 years with no possibility of parole in any way, shape, or form.
You hear about these DNA testing sites like Ancestry.com or 23andMe. Do they use kind of the CODIS type process?
At-home genetic testing companies rely on DNA data, just like the CODIS database does. However, the types of tests that they're using is slightly different. The difference there is the type of information that's getting out of the test. With CODIS, we're looking for exact matches. We're trying to identify individuals uniquely, whereas with these at-home genetic testing companies, they're looking for a completely different question. What is your heritage? What type of traits does your DNA exhibit that might have potential, health concerns down the road?
Has there ever been a case where information from 23andMe or Ancestry.com was used to solve a case?
I do know that it happens, and with more and more cold case investigations, I know that's a tool that's available to law enforcement.
What's on the horizon of DNA testing, and how much detail can we get from new technologies?
There's a new method called next generation DNA testing, and by using this next generation testing, they're able to provide a portrait of what the individual might look like based off of their DNA. So that is a very powerful tool in and of itself, to be able to take some unknown profile and provide a picture or an image of what that might look like.
Dr. B, in every great courtroom drama, there's that moment when the eyewitness identifies the guilty party. But have we really studied eyewitness testimony? I guess compared to DNA and fingerprints, memory seems kind of hard to quantify.
So funny you say that. Eyewitness testimony is so very important. Time and time again, juries are really impressed by the confidence and the strength that eyewitnesses bring to the table. But experts are now studying eyewitness evidence to ensure that it's being used in the best way possible. And for more on that, I spoke to Dr. Gary Wells, Distinguished Professor of Experimental Social Psychology at Iowa State University. Scientifically speaking, how reliable are our memories, and what impacts whether we remember something accurately or not?
Right. Well, I mean, memories can be highly reliable, but they can also be highly unreliable at times. There's really three things that have to happen in order to have a reliable memory. There's three sort of phases or stages. One is acquisition or encoding. You have to bring the information in and encode it. Second, you have to retain it in its original state. And then you have to be able to retrieve it. And something that disrupts any one of those three stages produces a problem with memory.
So how much do courts today, knowing what we know about memory, rely on eyewitness accounts?
Well, courts have always relied a lot on eyewitness accounts, and they still do today. Most all trials, certainly criminal trials, are attempts to reconstruct the past. What happened on this particular day or this particular time? One person after another ends up taking the stand and using memory to try to report on things that would help to reconstruct it. Eyewitness identification, identifying a person that you might have seen committing a crime, is still a very core and staple form of evidence in the legal system.
So do eyewitnesses get it wrong?
Well, they definitely do get it wrong, and with a frequency that I think has come along to really shock the system. Mistaken eyewitness identification is accounting for a lot of the DNA exonerations. In other words, we now have hundreds and hundreds of these exonerations of innocent people who were convicted by juries of crimes they did not commit, serious crimes. Some were sentenced to death row even, or life sentences, and then ultimately were exonerated based on forensic DNA testing. Over 70% of those cases are cases involving mistaken eyewitness identification. We've made a lot of progress in the last several years. What we've done is we've gone and worked with police departments in various jurisdictions, both in the US and in Great Britain. And we basically track every lineup that they do. And it turns out that 1 out of every 4 times that a witness views a lineup, they pick an innocent filler, someone who's put in the lineup just to be a filler. We know they didn't do it. So what we're looking at is like, well, how often do they make a mistaken pick on someone we know didn't do it?
If we know all of this, why do we still use eyewitness accounts if they tend to be so unreliable?
Eyewitness evidence is really, it's important. I mean, if we don't use it at all, if we say, okay, eyewitnesses are too unreliable to use, it's a lot of solace to perpetrators, right? Imagine that you're a perpetrator and the only witness is your victim, and you can't trust the victim. So what we've been doing is working on how do we make this evidence more reliable? Think about how forensic science is supposed to work. What happens is you take trace evidence, right? Trace evidence is something that the perpetrator left behind at the scene of the crime that can help determine the identity of the perpetrator. Well, in the case of eyewitness evidence, we need to start thinking of it as if it were more like trace evidence. That is, the perpetrator left something behind at the scene of the crime. It's in the mind or brain of the eyewitness, but still there's a trace. Now, how do we get that trace out without contaminating it? And so we need to start respecting the idea that you can't just start firing questions at a witness, that you really need a protocol. And that's what we've tried to develop, is a protocol for handling eyewitnesses and how you question them, how to interview them, how you conduct lineups, how you make records of all this, and so on. We've generated various recommendations for the legal system and law enforcement in particular about how they need to conduct their lineups. If you take an eyewitness and they make a mistaken ID, when they make wrong picks, we've long known that they're really not very confident in it. They're not very sure, but with only the slightest nudge, like, oh, good, you picked the suspect. Almost immediately, they begin to reconstruct the whole thing. They become this highly convincing, powerful, confident witness just from a nudge. So, for example, the person who administers the lineup and anybody else in that room should not know which person is the suspect and which ones are fillers, so that they can't cue the witness. And when the witness picks somebody, they can't nudge them or reinforce them or say, oh, that was the guy, all right. And instead, what happens immediately is you ask the witness for their statement. How sure are you? We actually have 9 large recommendations that we've made. One of them, for example, is that the entire identification procedure be videotaped. So let the jury see that this witness was shaky at the time. Let the jury wonder, how does a witness go from being shaky to being positive? And it'll never be perfect, but it's a great improvement.
So my takeaway from today's show is that forensic evidence and the advances in it is becoming pretty close to more than we can even imagine. But it really still boils down to having a single piece of evidence. And I think that's why it's really important for us to keep studying DNA and fingerprints in our memories. So what about you?
Dana, you are so right. We've come such a long way from the days of Kojak, Hill Street Blues, Miami Vice with Crockett and Tubbs. Just like every other field, science and technology have impacted forensics to allow us to better solve these complicated crimes. And that's QED with Dr. B. That's me. Find us on Twitter, Instagram, and Facebook, and we'll see you next time.
Our better data come from laboratory studies because we can control a lot more things. So we create events that people witness, and then we put together lineups and have them try to identify the person from the lineup. What we find is that, first of all, the common concern that a lot of people aren't surprised when we point out this finding that the ability to identify someone of another race than yourself, we make more mistakes than on our own race. And that's true not just for, let's say, white Americans identifying, African Americans, but also for Hispanics, Asians, anyone who's not a member of your group. It's also slightly true for age. So young people are better able to identify another young person than they are an older person, and to a slight extent also gender. So females are somewhat better with other females than they are with males, and males better with other males than females. But the biggest effect there is probably the race, or even not just race, ethnicity.
Production funding for QED with Dr. B is provided by
Battelle cares about STEM because it was part of our founding. Gordon Battelle, our founder, believed in building an institute that would actually better society through the use of science and technology. And this year we're going to hit a goal of 1 million students a year that we'll be able to impact around the country.
American Electric Power Foundation, boundless energy for brighter futures. And by viewers like you. Thank you.